So it's my pleasure to welcome Jim Carroll from Digica this morning to the UK AI podcast. And Jim, I'm looking forward to finding out more about Digica. Could you kick off by telling us about what Digica does?
Sure. So we are an AI software services company, with obviously with a specialism in AI. I know that lots of software companies say that at the moment. We like to think we're a little bit different because the majority of our technical team are data scientists rather than software developers. And what that means is that we can start with a data set, an academic paper, sometimes just a concept, and build AI solutions from the ground up. And then the software engineering discipline allows us to deploy those in real world applications.
Amazing. And I think one of the big challenges that businesses often face is really understanding how to use data and how to sort of embrace the data science. So do you find that going in with a team of data scientists, is that something which companies recognize that they need to have that specialty? Or is it something that you almost have to educate the companies on what data science is and how it works?
Our customers are pretty well educated, I would say. I had a call just this morning with a company who are want to build some financial AI software, and being heavily in the finance sector, these guys had already thought about the existing financial models, which work reasonably well, I guess, and they want to replace this with AI. They'd already twigged that this is not standard software development, and understanding some of the mathematics, the econometrics behind it is really important. So I would say that most of our customers are pretty well educated, but there are some people that we kind of have to start earlier in the process with, make sure they understand that we need a data set to start with, or we can help them gather a data set. But the point is, a data set is a key starting point.
And I'm keen to come on to synthetic data in a minute, because I know that's an area you specialize on. But I also wondered whether you could help us understand one of the challenges around data, which is often with bigger companies or even smaller companies, there's often legacy systems. There's data which has been put into different databases, different platforms, and then somebody's got a job of trying to meld it all together into a data set before we can use it. And that problem has become even greater when you add AI into it. But I wonder whether you're using now AI powered tools or any other data science tools to be able to help to standardize those different data from legacy systems.
So historically, what we would have done is, as part of an AI solution, you build some kind of pre-processing pipeline, if you like. So to ingest data from all the myriad sources that may be available, and then to get that into a consistent common format. But of course, the advent of language models has helped that. So the pre-processing pipelines still exist, but it's quite common to use AI tools such as language models to do that in an automated fashion. The old ways haven't gone away, because everywhere you go, there's some special niche system that's a little bit different. And great though language models and other such tools are, they don't solve all the problems. So there's still a requirement for some custom development in that regard.
And I suppose that's where the ability to have the data scientists who have a very high threshold for accuracy and a real understanding of the different types of mathematical processes that you could use to clean up data, that's very valuable, I imagine, then in that circumstance.
Absolutely. So data science in many ways is still a little bit of a Wild West activity, whereas software engineering that I grew up with has been around for decades. Software engineering has got a lot of discipline built into it to make sure that things like cars and spaceships and banking systems are robust. The data science world is still in the foothills of that, in my opinion. So the data scientists do a great job that the discipline of software engineering simply isn't set up for. Their mathematical skills are crucial in this, and the analytical skills too. My gut feeling is that over time, some of the discipline that's used in the software engineering world will move into the data science world. And of course, we're already seeing that today. I hope we're kind of leading that charge, really.
Yeah, yeah, interesting. I mean, I think I understand what you mean about it being quite early days for data science, but a lot of the core statistical models and the mathematics, that's quite well developed. But I suppose what you mean is in terms of how that then is applied into a business process, where software has obviously got a lot of methodologies and processes that have been kind of developed over the last 20, 30 years. Maybe data science hasn't yet got those same methodologies and processes.
Yeah, that's exactly the point. The smart thinking's there. The maths. I mean, I guess some of that goes back hundreds of years.
Yeah.
And that's all there, but it's only really in the last 5 to 10 years that it's started to become a mainstream technical activity. And so, whilst the smart people are becoming more and more prevalent, and their ideas are spreading, the techniques to make that into real world solutions are catching up. And that's why we kind of like to think that we're at the forefront of what we call practical AI. It's not just in the lab, it's real world solutions that we build.
Yeah, I like it. And I think that's the challenge often that companies face, particularly large companies now when they're trying to catch up. They know they need to do AI because their competitors are doing it, because their board has told them to do it. But actually, where do you start with that? And how do you identify what are the specific problems that AI tools could address? And then how do you get into that practical side of it? I wondered whether we could talk about synthetic data though as well, because I know that's a topic, an area that you specialize in at Digica. And I'd love to learn more about what you're doing in this space, how you're using synthetic data, and what the main applications you're seeing for it are.
Okay, yeah, you're absolutely right, Tim. It's a very big area for us, and the reason is that our single biggest, let's say, technology domain is computer vision, and there are a lot of computer vision solutions out there for doing all sorts of things. But our customers come to us with a really wide range of problems, and some of these are really difficult to solve. We can't just take off the shelf models to do that. So we train a lot of models ourselves, but to train models, you need data. There is a paucity of data for certain things. So I just want to talk about a couple of applications that we built where we've needed to create synthetic data. Now, in general, synthetic data is for computer vision, it's effectively renders of real life scenes. Works particularly well with regular shaped objects like mugs or mouse, but it doesn't do so well with people. So we built a tool chain for this based on some open source tooling. And the first application that I'm thinking of that we built was for a big industrial chemical company in Europe. They produce surfactants which are used in paints, and the problem is that what happens? They paint onto the wall, take a photograph of it, wait some time, take a photograph of it. In one case, they're trying to measure rusting. Of course, this is a process that happens over days and weeks. So it takes a very long time to generate data, not much of it. So we actually used our synthetic data tools to generate synthetic images of rust. And when combined with the real images, the real photographs of rust, we had insufficient data to train the models to measure. Rust's an interesting case, actually, because you think of it as a two-dimensional thing, but it's not. It's three-dimensional. So that's one case, which is and you can understand why there's not much data of that type around. But another more interesting case is where we were working on a system to detect meth labs for use in law enforcement. And yes, I did say meth labs. And the problem with meth labs is, or detecting meth labs, is that the kind of people that run meth labs don't publish photographs of their labs on the internet for obvious reasons.
Yeah, there's not like a little Google page for those.
No. So what we did was, again, we had to take some photographs, and we just took some photographs with chemistry equipment in a regular lab. It's not very realistic. So we built using our tool chain, a pipeline to generate synthetic data of meth labs using things that you see on TV or things that you can find on the internet as inspiration. And when we combine the real photographs and the synthetic data, we built a pipeline that was pretty effective at detecting meth labs. So that gives you a flavour that what we do ranges from detecting meth labs to watching paint dry.
So those are great examples, very different examples there. In order to get to the synthetic data, am I right in thinking that you would take those initial images of the early stage paint drying in 2 dimensions, as you mentioned, and then you're using your data science to predict, to extrapolate to what then the final synthetic data looks like?
Something like that, yeah. It varies a lot depending on the use case, but yeah, you start off with some photographs or a 3D CAD model of a shape. 3D CAD models of rust are difficult to do, but you can certainly do that for the objects that would be in a meth lab. And then from that, we render an image, we place objects randomly, but you have to apply textures to that. So a meth lab might be poorly lit, or it might be that there's dirt. So you're kind of using elements of randomness. So there's some mathematics involved there, but then there's an opportunity to use Gen AI to add another layer of realism on top of that. In the case of paint, we used a number of papers and mathematical descriptions of how rust forms to generate that. But it's on a case-by-case basis, really. The other interesting thing that we did was we used a similar idea for detecting instruments in a medical tray. Now, we didn't have the CAD models for the instruments, so we actually used a 3D scanner and then used our 3D design team to fill in the gaps where the scanner failed.
That's so really interesting. So in a way, you're taking the visual feed, reducing it to numbers, and then sort of building that up in a computer model, and then being able to kind of build up synthetic data based upon that sort of mathematical model you've created. So fascinating.
That's exactly right. It is fascinating. Sorry, Tim.
No, go ahead, please. Yeah.
I was going to say you can. An important point you raised there was reducing it to numbers. Some of the use cases we work on outside of computer vision are numerical. So, for example, we are predicting failures in wireless routers. That data is all numeric. You can apply similar techniques to generate synthetic numerical streams as well. So there are lots of ways to apply this technique.
Yeah, no, that's really interesting. But I think it really helps us to understand it in that visual way, and to how that's then reduced into that sort of numeric format, to then understand how other types of data sets, which are maybe not as easy to visualize as a meth lab or paint or rust, you're doing the same sort of process. How much of this is something which the companies you're working with understand at the beginning? Do they come to you and know that they need these types of processes, or do they come to you and say, actually, this is the problem, and then as part of the solution that you're sort of fleshing out, you then recommend using things like synthetic data and modeling in this way?
So sometimes our customers come to us with an idea of a solution. Sometimes, and more frequently, they just come to us with a problem. And so it's not just about, so it will be a simple problem statement. And from that, we will typically look at a data set to see if we think the problem is solvable with AI at all. And if it is, we'll build up a solution which will comprise the data pipeline. So for pre-processing, things like that. We will also build up a solution for what training and inference pipelines will look like, so the selection of specific models, technologies, and then we'll also it's got to be built into an application, whether that's running on your mobile or in the cloud. So we will devise an end-to-end solution, and that's typically, depending on the project, that's typically part of the very early stages of the project. So we get all that sorted out before we start building. So it's end to end.
And do you see that the companies you're working with, do they see this as something which is very experimental, or is this becoming more business as usual now for them?
The kind of things we do, it's often experimental. I mean, it's quite common for us to build an experimentation phase into our projects. And the difficulty with that is that experimentation implies that we don't know how accurate the solution will be at the end. It takes a pretty sophisticated customer to be able to do that. Not all people understand that AI isn't necessarily deterministic. We're all familiar with language models hallucinating. We may have seen computer vision solutions where it's confusing. It confuses a picture of somebody with the actual person. 100% accuracy isn't guaranteed. That's customers we deal with that have been in this space for a long time. They get that, and we devise ways of mitigating potential errors. Our customers who are less used to dealing with AI, we have to take them on that journey and help educate them a little bit.
Yeah, that seems to be one of the challenges, I think, which a lot of organizations are facing, which is how they go from that experimental proof of concept phase into actually sort of scaling it up and making it into a process which the entire organization can then use. And is that something that you see and that you also get involved with helping, i.e. changing the way that some of these experimental projects get turned into business as usual processes?
Absolutely. So let's say we've been through a phase on a project where we've assessed its feasibility, we've done some data collection, we've done some prototyping, we've built a model we're happy with, and then we built a beautiful software framework around it and deploy it. Like all software, when you put it into the real world, users do unexpected things. So it's very common for us to work with our customers to continue the development, to enhance accuracy, to maintain the system, but also to educate users as we go along. New users will come in who aren't necessarily familiar with the idea. So we don't like to work with our customers on a short project and then that's it. We like to take them on a journey, go with them on that journey through the evolution of that product and the deployment in their business.
Yeah, and one last thing I wanted to sort of get your thoughts on, which is how do you measure the success of these types of projects? I think it's one of the things that I see a lot of organizations sort of struggle with, because there's this tension between the company that's investing the money in using a new tool. They want to see the return on investment, and then there's the company who's delivering, whether it be consultancy or the software or the tool, and they have to kind of like try and deliver some, or they have to try and predict some sort of KPI that's going to deliver that return on investment for their customer. How do you see this emerging? Has it been hard? Are your customers asking you for those return on investment numbers, those KPIs, and how do you predict what that's going to be and measure the success?
So in the early days of Digica, we were able to talk using very technical language about the kind of metrics that would measure performance. So you might talk about precision, recall, F1 scores, intersection over union, things like that. These are all very technical metrics, which are very helpful for technical people, but they don't help business people. They don't know what precision or recall is. So increasingly, we've had to think about what is the business value. It's not always easy for us to put numbers on that, But again, let's think about an example. Let's think about an example. If we're in a warehouse and we're trying to count, and we're using some AI to count products that are stacked on shelves, if we can do that with a camera or a set of cameras in real time, so you have a dashboard giving you a count, then what the time you have saved is some people with clipboards wandering around the warehouse. And so that's how we demonstrate that. Of course, we don't always know what the numbers are, but increasingly we have to talk about what that is. Because if all the cameras are going to cost more than the guy with the clipboard, what's the point?
Yeah, no, that's a really good point. So I think it's almost understanding the current cost of delivering the non-technology based solution, and then looking at what the technology solution could create in terms of the savings there as well. Amazing. Well, Jim, we've covered a lot of ground there. Thank you so much for sharing about Digica's work and what you've been doing there in a number of areas, synthetic data. We've covered a whole bunch of areas around how companies use data and the ROIs and KPIs there. It would be great to understand how we could find out more about Digica. Could you tell us how we could stay in touch and find out more about Digica?
Absolutely. So we have we've got a large number of use cases published on our website, so you can always find out more information there. If you have a specific problem you'd like to talk to us about, please reach out to us through the contact sheet on our website.